Laplace correction for Newton's formula. So in the previous lecture we saw that Newton gave a particular formula for velocity of sound. What was the assumption made by Newton? According to Newton, the sound wave propagation is an isothermal process. But Laplace, according to Laplace, he said this is not true. Sound wave propagation is an adiabatic process. Sound wave propagation is an adiabatic process. Now, what is an adiabatic process? In heat and thermodynamics, we have learnt that adiabatic process is a process in which heat exchange is zero. So, if heat exchange is zero, in that case, there is an equation which is related to an adiabatic process. About this equation, we will learn more in thermodynamics. So, this is called equation of adiabatic process, which is PV to the power gamma equals to constant. In the previous lecture, we had PV equal to constant, where PV is what? Pressure into volume is equal to nRT. So, if N becomes constant, R becomes constant, T, temperature becomes constant, everything on the right hand side becomes constant, hence that is an isothermal process. But in case of adiabatic process, PV to the power gamma equal to constant. Now, sir, what is gamma? So, this is there in thermodynamics. Gamma is nothing but the ratio of Cp is to Cv. What is Cp? Cp is known as specific heat capacity, specific heat, let me take it on the other side, capacity at constant pressure, whole divided by specific heat capacity at constant volume, Now, what are heat capacities? That we have learnt already in thermal properties of matter. So, gamma is the ratio of Cp is to Cv. And what is Cp actually? What is the mathematical relation? That we will do in thermodynamics. And this red equation represents the equation of adiabatic process. So, Laplace modified the Newton's formula for velocity of sound. How he modified? Let's differentiate the same. The method is same. We will differentiate this whole equation. And on differentiation, it will be d by dv of PV to the power gamma is equals to d by dv of constant. Derivative of constant is 0. So, let's move to the right hand side, it will be 0. And left hand side, we will use multiplication rule, which is there in differentiation. What is the multiplication rule? It says v to the power gamma dp by dv. We differentiate the p pressure first, then plus p as it is differentiation d by dv of v to the power gamma. Let's proceed. So, differentiation of v to the power gamma will be nothing but p into gamma into v to the power gamma minus 1, and here we left with v to the power gamma dp by dv equals to 0. Let's multiply. Before multiplying, let's make it discrete. So, this dp can be written as delta p upon delta v plus p into gamma into v to the power gamma minus 1 equal to 0. Multiply the whole equation with delta v, and this will give you v to the power gamma delta p plus delta v into, because there is no delta v here, so multiplying the whole equation will add a new parameter in the second term, p gamma v to the power gamma minus 1 equal to 0. Let's take the first term on the right hand side. It will be delta v into p gamma v to the power gamma minus 1 equals to minus v to the power gamma delta p. Now, taking all other parameters on the right hand side and keeping pressure p on the left hand side, it will give you minus v to the power gamma delta p upon delta v into gamma v gamma minus 1. Now this expression v to the power gamma and this expression v to the power gamma minus 1, taking this v to the power gamma minus 1 on the numerator will make this as minus v to the power 1, because gamma and gamma cancels, delta p upon delta v, and this extra gamma will be in the denominator, this one. Now this whole thing, v delta p upon delta v, this we have already learnt in the previous part. It is nothing but the bulk modulus. So this will be minus, including minus, it will be bulk modulus upon gamma equal to pressure P. And this can be written as B equals to gamma P. So in case of speed of sound, velocity of the sound will be root under, instead of bulk modulus, we will put gamma P upon rho, where gamma is the specific heat capacity ratios.